Okay. Morning, everybody. Thank you very much for coming to today's breakfast seminar. Today we have Teresa. Teresa is one of the ISR's new PhD students starting just this year, and she's going to give us a bit of an introduction to her PhD project.
Well, hello. I haven't done much yet, but just trying to share with you the ideas I've got in my very messy head, and well, if I can get some more from this lecture. So basically, my thesis topic is about how to recuperate nutrients from wastewaters to sustainably produce fertilizer. So I don't know how much you know about this topic. I suppose that here is quite interdisciplinary, so I'm not going to enter into much detail, load your heads with formulas and so on. So why is sanitation needed? Well, there's a very basic need of safe water provision, of not getting sick, and also because polluted water is very negative for the ecosystems. It can damage them a lot, and that at the same time decreases the capacity for them to deliver services. As you can see, the dead fish, or even to drink rainwater is not safe at all. So the situation is very different in the developing world and in the developed world, and hence their aims are not exactly the same. Here we've got a very extensive sewage networks that have been established for a long time. The waterborne diseases are now rare. Before they were common, because the good thing about sewage systems is that they are very effective in rapidly removing all the pathogens out of us. So the less in contact with them, the lower chance you have to get sick. So it's all much control, and then, well, monetary constraints there always are, but they're not so high. And the legislation, as it has been running for a long time, is very strict, especially with health regulations, and with environmental. Well, they are strict, and they are increasing in that as well. And the business has been long established, so hence the framework is completely different, and the approach is completely different. And practically, the wastewater treatment plants are everywhere, and it's the only solution that there are. There are some, I saw some figures in the UK. I think it was 98% of the people were served by wastewater treatment plants, and there were just remaining at 2%, like really small villages that may be served by septic tanks. And so here, once the people is safe, now what they are looking more at is in how to make them like more sustainable, in the sense of producing less amount of sludge, trying to reduce it, and also they are looking forward very much in producing methane for biogas. In undeveloped world, the scheme is completely different. In many places, there's not an already built infrastructure, which that means that it's scarce, and the approach is rather to see which kind of sanitation system you could put from the beginning. By scarce, I mean it's generally served by big lattice that is basically a hole in the ground, and the thing accumulates there. And waterborne diseases are much more common, because the ways of treating it, their effectiveness is not very reliable, and in many cases there's not even a bit. I think there's not even nothing. If the monetary constraints here are high, they are even higher, and the health and environmental regulations are more flexible in the sense of their application, and in the sense that it's not really well regulated. So, and the business many times is new, so it's more about planification, and they're looking many times for low-cost sanitation systems, many times dry. For instance, I worked with this case study. I'm going to briefly present you that it's in Durban, in South Africa. So when you have the picture of Durban, you have like a big city, and it's true. it's fairly well it's developed, but around what is the city, there are a lot of peri-urban areas, very, very poor, and rural areas where there's no sewage system whatsoever. And the problem is as well that many times the villages are like scattered and very small and remote, and there's no access to them, rather than by a really small sand road. So actually to be thinking about of putting there a sewage system is very difficult. So really that now is kind of an experimenting area where they are suggesting many, many different ways, alternatives of dry sanitation, and they're trying to see what's best, what's worse. What they used to do in the past was the big latrine, so it was a big latrine, and once it's full, they block it and they built another one. So in the end you have all the landscape full of big latrines, and it's not very, very safe. What they do nowadays is to empty them manually with, well, it's cheap, but there is some risk for the people that has to empty it, obviously. And they empty it once in every 5 years, and the sludge is not treated but delivered directly to landfills, to the sea, or incinerated, most of the times to landfills. And they are suggesting different technologies, as for instance the Landfill machine, that what it does is to treat the sludge to reduce the amount of solids for final disposal by drying it and heating it, and also to kill the pathogens so that it could be sold as sludge conditioner. And another alternative that they're thinking of is a urine diverted toilet, by which they separate urine from feces. The urine is stored to potentially use it as fertilizer because it's very rich in nutrients, and the feces are just buried because well, they could be used but they're not very, very safe. So just now they're not doing anything with them. And I'm also comparing it with this other scenario that doesn't exist, but just to compare, by which the excreta could be accumulated in septic tanks and then sent to a wastewater treatment plant. So that you get an idea of the amount of mess that this is for 1,100 inhabitants. That is really not much. You've got in the traditional scenario, you had like more than 150 meters cubic of sludge generated per day. That it's a lot, so that's the need that all this needs to be controlled. But it's quite expensive, so obviously that one was the most economic alternative, but not the most environmental friendly. And with the Ladeba, it was quite good. The idea was that on the one hand you separate what is rubbish from the sludge, and the sludge you heat it up and you reduce the solids so it can be used as soil conditioner, and the rubbish is disposed. So the amount of disposal is much, much lesser, and although the sludge center soil conditioner didn't pay up for the technology, through reducing sludge disposal, this alternative was more or less the same price as not doing anything with it, or in fact a bit cheaper, and much more environmentally friendly. And we're looking at nutrients. This would be the amount of nitrogen generated per day in the same population. The main source is urine, which is we're talking about ammonia. So that's why they say it has a large potential for producing fertilizers. And in this case, it will go with all the organic part in the sludge, implementing Ladeba. Problem is first that plants like better nitrates than ammonia, so ammonia is not the best molecular composition for using as fertilizer. Problem number 2 basically is that it's a very, very unbalanced fertilizer. Here we see a phosphorus. That phosphorus is the even more interesting than nitrogen, because nitrogen you can you can fix it from the atmosphere, so it's possible to generate it. But phosphorus, we all know that the resources are limited, and it's getting more and more expensive to mine it because it's becoming more and more rare. And there is some phosphorus in the excreta, although the amount's much lesser than in nitrogen. And if using directly the urine as fertilizer, it's very imbalanced in the sense that it has an NP ratio of almost 10, and normally fertilizers are in the range of 1:1, so the same amount, and a nitrogen-rich fertilizer, we'll be talking about 3, 4. So it's really, I mean, if you need to put a lot of nitrogen for once, it's okay, but to use it generally, it could even be worse, because it can burn the plants, and also because the soil could become poor in nutrients because of having too much. It's a bit complicated, but you need to add them in proportions it is. And here I compare here you can see the sludge flows in the dry system, that it's fairly contained, and when we take into account a wet system, this is a low flow store, that you have to take into account that normally the normal flushes, there are 12 liters per flush, and this one is only 6, is another one. And you can clearly see that the amount of mess is much larger because of the water, that really the amount of recuperated water that it's clean and you can discharge is fairly small if compared to the one you use. And the final sludge that you need to dispose is already dried and completely treated is normally the average of a 60% of what it enters the system. And all the technologies all around the system are very expensive. But it's the only option in developed countries. So basically, what's a wastewater treatment plant? But it would be a very basic scheme. The sludge enters in primary treatment. That basically what does is get all the gross material out of the water, plastic, rubbish, and also like gross organics. From there you start getting the sludge, and then the water goes into the aeration tank. At first it was only to reduce the amount of organic matter, and afterwards now what is widespread is to also remove the nutrients. So what they do is, instead of going directly to the aeration tank, here there are kind of an anaerobic chamber and an oxic chamber, an anaerobic chamber depending on the amount of oxygen you put, so that you, apart from removing organic matter, you remove phosphorus. This is the enhanced biological removal, and you also remove nitrogen. Really the phosphorus is not removed, it's actually all is concentrated in the sludge. It's taken out from the water, 12%, but it's only in the sludge, so really it's still there. And there is some elimination of nitrogen, because the nitrogen is first converted from ammonia, from the input to nitrate, and then from nitrate to nitrogen gas. So there is some, although it's also accumulated in the sludge, so the sludge needs further treatment because it's where everything is concentrated. And this is generally done through anaerobic digestion that has first the aim of reducing pathogens, because very high temperatures are generated, the pH also changes, there are generated acids and so forth. And also you can get methane out from here that normally is used on site to heat up these, and also in the plant. For instance, the most expensive part of wastewater treatment is to aerate. So, I mean, right for now, this doesn't make up for all the energy costs, maybe 40% as much, it's not bad. But this could be improved, and then everything would be much better for cost effective. And then the nutrients remain in the sludge after being treated, so hence the sludge could be used as fertilizer. In fact, in the UK, they've been supporting it very much over the last decades. Here I've got some data. In 1996, it was nearly the 50%, and but then they banned the possibility of directly delivering the sludge into the surface waters, which was a very good idea in my opinion. And then it has been increasing, and now it's nearly a 77% that it's going for agricultural land. Alternatively, it can go to landfill, which is very expensive, or it can be incinerated. Depending on the compost it has, maybe the only possible route is to be incinerated, and because of the high cost of landfill, in fact, here I've got an extract from Water UK. It's really the only alternative that they're thinking about. But for the sludge, you can sometimes they get energy from incineration, and sometimes not. And in fact, they want to support very much again the anaerobic digestion in the future, looking for energy, basically to use locally or to inject for the grid. Although, and also inclusive not only in wastewater but also use it from other types of waste, because you can digest anything that is organic really, and then use it as organic fertilizer and soil conditioner. And they are very ambitious in these assets. They've designed a series of key milestones, basically through the landfill directive, that it's becoming more expensive. Here you see that this year the tax would be £72 per ton of sludge. That take into account how much sludge the wastewater treatment plant generates. It's very expensive. So reducing the sludge directed to landfills and increasing biomethane production through the carbon budget. The only problem is that really the gas you produce in digestion is not very clean. You need to further treat it, because apart from methane you get CO2, you get sulfurs, you get water, and you need to clean it up a little bit, and something has to be done there. And but the problem is that it is true that there are many hazardous compounds in the sludge. Depending on what you're treating them, or if you're just treating an agricultural area, there won't be many. But if you're treating a city as London, the industries, they're regulated, but they deliver hazardous materials into the water and then go to the wastewater treatment plants and then go to the sludge. So the environmental regulations are becoming very, very strict with this regards, and are limiting the possibility of large filtration. So there are two ways basically of applying sludge. One is directly, here we see, and the farmers like this because apart from providing nitrogen, it provides moisture to the soil, which is also good. Or you can extract struvite from it. That is a bit more complex system by which you get the sludge and you thicken it, and then once thickened, you separate the solid phase from the water phase, and that water phase is very, very rich in nutrients, and it's what you use to precipitate this solid compound that would be the fertilizer. Only that, well, the technology is a bit needs to be controlled, and you need to put many chemicals in it, and also it's an expensive technology. The fertilizer is a very balanced one, nitrogen and phosphorus, hasn't got potassium, that is another nutrient that plants like, but well, it would be easily added. And well, the technology, it has to be whether it's cost effective, because it is a chemical reaction, for instance, for settlements in karstic area, calcium carbonate decrease very much the effectiveness of the system. So there are several constraints, but the reality is that nowadays they are they are limiting very much the right application, and for crops that are going to be eaten, and for urban environments, practically we should say that's true, it is the only one. But well, I mean, they say it because they consider that sludge has more hazardous materials, but the reality is that, well, sludge, for example, large organic compounds like PCBs remains in the sludge, but pathogens, I think they could be in either, and well, yeah, could be more in the sludge, but you do find heavy metals in the struvite as well. So there are many gaps in everything. Still, so basically, what does this need? Well, needs to minimize costs in this context, and needs to minimize the treatment plant could be seen as a system where you want to minimize costs, basically minimize the production of sludge, and maximize revenues by maximizing biogas yields and trying to reduce the sludge with these limitations, and this has to do a lot with optimizing the anaerobic digestion of treatment. So this is basically what anaerobic digestion does, transforms the organic matter into the simplest compounds, CO2, ammonia, methane, also other gases, and methane can be used. So co-digestion is an opportunity, and in fact the UK is supporting it very much. I've got a few slides afterwards. So basically what this is to treat sludge with other wastes. Why is it good? Because the sewage is very rich in nitrogen, ammonia, we've seen from the urine. So this means that the bacteria don't have enough carbon to do this process adequately. In fact, there are many process constraints because sometimes it's very limiting, and also because of the other hazardous materials that obviously, if heavy metals are toxic for us, they are also toxic for the bacteria many times. So one alternative is to use carbon-rich materials like vegetable waste and milk. So you get, on the one hand, more methane, and this means that if you get more methane, you get less sludge. That is a good idea. And also, if we're talking about nutrients, here is a slogan that especially Ecosan has been using a lot of closing the loop by recuperating the nutrients from urine and feces and use it as fertilizer. But the truth is that this loop, as this is not closed, very simply, it's just a slogan, basically because you eat a very small part of the plant. So all of that is also nutrients, or biomass and nutrients that you're not wasting. And also because you need to eat a lot of plants to actually be useful for you and generate a person. So the higher, this is a pyramid of biomass, basically says that to generate 1 kilogram of biomass is the 10% of what you have to eat from the lower chain. And we are basically top carnivores when we eat pigs, or we are primary carnivores when we are eating cows, and most of the time we are more carnivores than herbivorous. So really the thing is that here there is a lot of waste that is not being used, and really the human excreta is just a tiny little bit of all this nutrient loop. So in order to close the loop, you would need to recover nutrients from somewhere else, because the nutrients are everywhere. Ecosan, the latest, that's why in the developing countries now they are also looking at solid bio-waste to composting and all that. And in wastewater treatment plants, the UK is also looking a lot at co-digestion, and in fact, here you see they want to, basically the UK wants to be like reference in Europe in digestion, in generating gas from it, and they're looking a lot at co-digestion. But I think they are very clever, because they say, yeah, we want co-digestion and we want to use the water industry to do it all. And well, it can do it. You can maximize the efficient use of the existing infrastructure in the wastewater industry, and it's a good idea. But the industry has its limits. You cannot just overload the existing treatment plants with a huge amount of other waste, because the system will collapse. So here I think, well, we're talking quite a few opportunities of the for the industry that may be looked upon, and also because different waste have different regulations, and who is going to get the revenue from the energy, as well as who is going to account for the costs. It's quite an abstract thing that maybe you could look up. It would be very interesting. And so with all of this, there are different things I'm asking myself. First, I've put it colors depending on how difficult I see to answer them. First, I've been seeing in developing countries what would be the alternatives, and whether it's worth to separating or not, and what could be the nutrient potentiality or what would be the potentiality of recuperating nutrients from excreta. I think that is more or less already answered. I asked myself as well whether it's worth cost-effective precipitate through it from urine and from a wastewater treatment plant. That would be digestion from urine. I think it wouldn't worth a lot because of this imbalance, because really what you precipitate is the same amount of nitrogen and of phosphorus. So once the phosphorus has finished, you don't precipitate anything else. So digestion is more the digestate is more balanced, but then it also has many more compounds that may reduce the effectiveness of the system. And then another thing I would like to look upon, I'm very interested now, is in sludge management of optimization, in the sense of how to get less sludge, more biogas. And I consider that waste composition and co-digestion has a lot to do with this, in the sense of what would be the optimal way of doing that, what kind of compound you would like to mix up in what quantity, and how effectiveness this is. And further on, I asked myself, and I haven't seen anyone that has done it, and I don't really know why. But all the literature refers of co-digestion, but really, in the secondary treatment, they have exactly the same problem, that the waste is very unbalanced, and the amount of nitrogen is very high compared to the amount of carbon. So I think that if instead of just co-digestion you included a bit of co-treatment, everything could go better. And in fact, also because there are problems related with co-digestion, operating problems, and perhaps if instead of doing sewage treatment plants with co-digestion, doing combined treatment plants, I don't know, could work. So maybe with modeling I can figure this out. But of course I'm open, and if you give me more ideas, very much.
Thank you, that's really interesting. Any questions for Teresa? Anybody? Questions? No questions.
Ideas?
Suggestions for a Teresa's project?
Teresa, just earlier on you were talking about improving the carbon content, so you want to increase that carbon going in. Okay.
Yeah.
Just
COD.
and what do you suggest doing? Adding.
The problem is that the basic problem that both has is that the amount of easily biodegradable carbon is very low. So vegetable waste and meat waste, there are a lot of sugars there, and that would increase the amount of readily biodegradable carbon, and it would balance more the situation. So this means that the microbial community will grow better, faster, and will be more efficient in processing all the organic matter. And in a specific case of biogas production, in addition, methane is made of carbon, not of nitrogen. So really, you want to put there things rich in carbon in order to produce it. And the problem with nutrient removal that I was going to say as well is that in the case biological removal, to remove the phosphorus, especially to put it inside the sludge, you need to have readily biodegradable carbon as well. And sewage is not usually that good. So in the end, that is a shame. Many of the wastewater treatment plants that are supposed to have enhanced biological removal, they just add some chemicals like ferric aluminium to precipitate it. And the problem is that then you generate more sludge, it's more expensive, and in theory you cannot use this chemical sludge for agriculture because it has hazardous materials.
I think some wastewater plants are speaking to someone with adding more methanol. I think they're doing experiments.
Yeah,
methanol,
they're doing experiments with methanol, with
Uh-huh.
milk, with and in fact, well, I think they're still very missing that. But what they are considering is a framework of co-treating waste from urban waste like vegetables and food and so forth with the sewage. And they're considering very much in the legislation. The only thing is that you need to be careful what type of waste, because they say that if it comes from vegetables it's okay, but from meat not. I mean, you wouldn't be able to use it afterwards. So it's what kind of waste to mix with what, and the composition also has to match.
Any more questions? Nope. Nope. Right. Teresa, thank you very much. That was fascinating.
Thank you for coming.
Got yourself to some more pastries and bread, and thank you very much for coming.